Hi, I'm John Street, and isn't Wyoming beautiful? You know, I've been teaching people about outdoor skills and safety for more than 25 years, and I'm delighted that the Brunton Company has asked me here to talk to you about compasses and how to use them. You know, the compass has been around for thousands of years, and the first ones were pretty crude and simple. They were just no more than magnetized pieces of metal that had been rubbed over stones and either suspended from a string or maybe placed or suspended on water. Before we learn about the compass, I'd like to give you a real important tip. And that is, before you go out into this beautiful land, do a little pre-trip planning. Have the right gear. Know about nutrition. Have good rest. And make sure you've studied the area and used your map and compass in pre-trip planning. Let's go down by the water, and I'll show you some different kinds of compasses, and we'll begin to learn about the ABCs of the Brunton compass. You know, before we start talking about really how to use a compass and the ABCs of compass use and navigation, I'd like to just show you some different kinds of compasses that are on the market today. And one of the neatest ones I've found, I carry with me all the time. I carry a little pocket survival kit, and the Brunton folks have made a little disc compass that you can peel out of one of the instruction cards, and by just scooping up a little water and suspending this disc on the surface, you've got a compass. But then you may elect to use some of the more modern varieties of compasses. This is a pull tab compass that I keep on my day pack. There are other kinds too. These pin-on models will go on your jacket or shirt, or you can even pin them to your watch band for a wrist compass. Clip-on compasses are neat like this too. There's prismatic compasses, and then there's the old standby, the pocket transit. But the compass I'm going to use to teach you how to navigate and the principles of compass use is this map compass right here. Now let's move out into a meadow where we've got more room, and we'll find out just how and why a compass works. You know, I showed you some different kinds of compasses down by the creek, but I'd like to show you the parts of this compass, tell you how it works, and show you how to use it. First of all, this compass has a base plate, and it's divided up in measurements that we can use with maps later, and the all-important arrow that indicates the direction of travel. The white portion is the azimuth ring. The azimuth ring is calibrated in 360 degrees, or a complete circle, and the 4 cardinal points of the compass: north, east, south, and west. This azimuth ring surrounds the compass housing that is liquid filled, that contains the magnetized compass needle. If I hold this compass level so the needle swings freely, it will always point in a single direction, and that's to the magnetic North Pole. The Earth is surrounded with a magnetic field, and that field is centered just above the great Hudson Bay in Canada, and that's what we call the magnetic North Pole. And we can use that as a reference point with this needle to find our direction. Once we know how this works and we can position the compass properly, we can find our direction real easy. Let me show you how, but there's one caution, and that is, when using the compass, remember it's a magnet, and it's sensitive to other magnets or other compasses and large metal objects. For instance, if you held a pocket knife or had a big belt buckle and you got it too close to this compass, it would influence the needle and cause it to point in the wrong direction. You want to be careful about gun barrels and backpacks and other metallic objects too. But let me show you how easy it is to find a direction and take a bearing. Let's say we'd like to take a bearing from where I am to this tree. The way you do that is simply hold the compass base plate level above the waist so you can see all of the components easily. Rotate your body around and face the direction you want to go. Point the direction of travel arrow at the object, and then simply turn the azimuth until the red orienting arrow is directly under the red north indicating needle. And then I the degree reading right behind or right over the direction of travel arrow. So now that I've shown you a simple way to find direction or find out your direction of travel with this compass, I'd like to show you how to use a map and a compass together. There's a number of maps that you can use to travel by. For instance, we are most accustomed to using a road map for our cars, but out in the wilderness we've got hiking maps and trail guides, national forest maps, but the one I really like to navigate with and the one that we'll use is the United States Department of Interior Geological Survey map. And let's look and see what it really looks like. I'm going to spread it out here on the ground so we can see it. Along the sides of the map, we'll see the township and range lines that correspond with the Earth's latitude and longitude lines. Latitude lines run parallel to the equator and are even distances apart. Longitude lines run from the geographic North Pole to the geographic South Pole in even distances. Latitude and longitude lines are used in world geography for navigation and location purposes. Other lines on the quadrangle map are small brown lines that are called contour lines. These lines represent changes in elevation at intervals that are indicated in the map's legend. And you'll find elevation numbers every 5 lines apart. And that gives you the elevation, and it also gives you some indication of how steep slopes are or just what the topography is. By interpreting these lines, you can see where travel would be difficult or impossible, and therefore you can use a map to plan your cross-country trip before ever actually seeing the area. Now let's find some landmarks that we can see here and on the map. Right below me is a switchback road, and if I look on down I see a valley, and across the valley I can see another road and some buildings. And then if I look on along the road carefully, I can even tell where the dirt road becomes paved. Other prominent points are the cliffs and the points of rock outcroppings that are all visually distinguishable, and I can easily find them on the map. The legend provides written information pertinent to reading the map and is the key to map navigation. There are distance or linear measurements or scales. And also you'll find located in the legend arrows that will provide the direction of geographic north, grid north, and the all-important magnetic north. You must be able to adjust your compass to compensate for this magnetic declination in order to navigate accurately. So that you can understand just how important it is to compensate for this declination, declination varies 44 degrees in the lower continental United States alone. In order so that you might understand better what declination is, you can see that the magnetic North Pole and the geographic North Pole are not in the same place. Actually, the magnetic North Pole is located just above Hudson Bay and moves from time to time. And so that's why it's important for you to refer to your geologic or geodetic survey map or your isogonic chart in order to navigate properly. At a point where the magnetic North Pole and the geographic North Pole were to line up straight with each other, there would be zero declination. Or if the magnetic needle on your compass points west of true north, it is called west declination. If it points east of true north, it is called east declination. Now that we've talked about the compass and you've seen the map, let's put them together and show you how to navigate with them. Remember, first of all, check for the declination angle at the bottom of your map. And check and see that your compass has been adjusted for that angle. If it hasn't, that's the first thing you need to do. And these Brunton compasses, you don't need a tool for that purpose. You simply grab the housing and hold it in place and rotate the azimuth until the east or west declination has been achieved. In this case, on this map, that angle is 16 degrees east, and it's just this simple to set. Then it's a matter of A, B, and C. First, A, simply align your compass on the map so that the long edge of the base is on a line from your present location to the desired destination. B, bearings are found by holding the compass steady and rotating the dial so that the N on the dial is pointed north on the map. Your bearing now appears on the dial at the direction of travel arrow. C, courses are followed by picking the compass up and holding it in a horizontal position so that the magnetic needle is free to rotate. Then pivot yourself until the orienting arrow is aligned with the magnetic needle. The compass now points in the direction you need to travel to reach your desired destination. Well, I've already used the ABC method to find my heading and my bearing that I'll travel. But the last thing I want to do before I actually walk off from this location is to check things from the map to the ground. So we call that orienting the map, or putting the map in the right perspective. And the way I do that is simply, I've already dialed in my declination, and I turn the map and put it in its proper relationship. Once my orienting line and my arrow are lined up, then everything on this map is in the same perspective as it is down in this valley. So I can look from where I'm starting right down toward the bridge. Well, there's the direction I'm supposed to go, but I can't really see the bridge. But by using the compass and taking this bearing and walking in a straight line, I can get there. And it's just as simple as that. Well, the map and compass got me here, and you can develop skills just like this too by studying and practicing a little bit of these very skills that we've taught you in this tape. You know, I'm glad I got here too, because the weather's really changing, and you never want to really be too far from your gear if you're in the mountains. Just look at that weather. I'd like to recap what we've learned up to this point. So far, I've introduced you to the map and compass. We've learned the ABCs, or Brunton's way of placing your heading or bearing on a map, and we've oriented a map and come cross country. Now I'd like to show you the map and compass in use in a variety of environments and teach you one more skill, and that's how to find yourself through triangulation if you become lost or disoriented and confused. Just a few minutes ago, the weather wasn't like this, and the forecaster didn't tell me about it either when I made my pre-trip plans, but you should really expect weather like this in high altitudes and always be prepared for them. In my pre-trip planning, I plotted my course, and I don't want to stay up here, so I'm going to try to get to a road that lays between here and Fossil Hill that, according to my map, is right over there, but I can't see it in this fog and snow. But I can follow my line of travel, and that's a good navigation point if you've got a map and a compass with you. My last bearing was this tree, and I can't see the mountain, so I have to take shorter points of bearing. And I'm just going to move this time right down to these trees, and they're right on line. Boy, this sure in the mountains of Wyoming. In fact, there are no mountains here in the East Everglades of Florida. But what you can do with a map is still find physical features that you can navigate by. Some can be man-made. Look at this power line. Now you can find a power line on a map. There are other man-made features too. Remember houses that are shown on the map. Radio towers, fire towers are all good navigational tools. So don't overlook them. There's some real subtle points too in navigating. You know, when you're traveling cross-country, just simply keeping your shadow on the same side of your body as you go along will tend to keep you in a straight line. Now I'm going to show you another compass and map technique called triangulation. Well, I'm on a road here and it's one of these switchbacks, but I'm not sure which one it is. And by looking at two known objects and using my compass, I can find out exactly where I am. I can see that rock outcropping on my map, and that's Fossil Hill up there. So with those two known objects and a map and my compass and taking bearings, I can find out exactly where I am. My bearing to the rock outcropping is 94 degrees. And my bearing to the Fossil Hill is 172 degrees. Now it's simply a matter of constructing those two headings from those two locations, and where the lines transect is exactly where I am. The way you do this is to first orient your map to north as we showed you earlier. Then construct lines away from the two bearing points. Rotate the azimuth ring on the compass until you have the desired degree of bearing directly beneath the direction of travel arrow or sighting line. Then place one of the sides of the base plate on the point on the map where you took your bearing. Rotate the compass around this point until the red magnetic needle aligns with the red orienting arrow on the bottom of the base plate. Then draw a line on the map. Repeat this process for your second bearing point. The place where the two lines intersect is your exact location. Well, we've covered the map and compass and those skills associated with it, and I hope that you've learned something in these last few minutes. But before I leave you, I want to recommend that you really make an effort to learn the skills and use of a map and compass. There's a lot of fun and exciting games that you can play. Orienteering's one that will sharpen those skills and help you travel in the outdoors better. I thank the people at Brunton, and I want to extend the great outdoors to you. Hope that you go out and enjoy yourself safely, and if you learn this skill, it'll make outdoor travel a whole lot more fun.
Contact the U.S. Geological Survey for topographical maps at area code 303-236-7477 or write to this address. For more information about compasses, contact the Brunton Company at area code 307-856-6559 or write to this address. For other outdoor skills videos, contact Survival Research Associates Incorporated at 1-800-VIDEO-FILM or write to this address. To learn more about the sport of orienteering, write to the U.S. Orienteering Federation at this address.